Past exam questions on trigonometry. You've got a formula sheet at the front. Make sure you, of every exam paper, make sure you're aware of that because you will need some of it. Question 1. ABC is a right angled triangle. You've got the length of a couple of sides there and you've got to find the missing angle x. First thing you need to do, you need to recognise you need to use sine, cos or tan to do this. We're going to label up the sides. The long side is always the hypotenuse. The side opposite the angle that we've got, or we want to know, is the opposite, so that's opposite, and the adjacent is the other side. And you need to remember that sine is opposite over hypotenuse, cos is adjacent over hypotenuse, and tan, or the tangent, is opposite over adjacent. I remember it as some old hags carry a huge tub of ale, but you might have your own way of doing it. Here are your workings for it. We're going to use cos because it's the adjacent and the hypotenuse that we know. That's why we're using cos. So because we're finding an angle, we've got to use shift cos to find the angle, and you should have got 39.323. To three significant figures, it is 39.3 for 3 marks. So it's 2 marks for working out that, 1 mark for rounding to the significant figures. Question number 2. Here's a right angled triangle. Calculate the angle. This is pretty much the same as question 1, only the numbers have changed. We're using cos because that's the hypotenuse, that's the opposite, and that's the adjacent. So to find a missing angle, we use shift cos, so that's why we're using shift, and to 1 decimal place, 51.3. Here's another right angled triangle. Calculate the value of y. First of all, like we always do, we've labelled up the triangle. So you've got your hypotenuse, which is your long side, your opposite, because it's opposite the angle we know, and the adjacent is the other side. We want to use the adjacent and the opposite, because we know the adjacent, and we're interested in finding the opposite. So tan, which is tan, opposite over adjacent. Tan 40 is y over 12.5. Multiply both sides by 12.5, because we're rearranging it, so that's 12.5 times tan 40, which gives you 10.4887. To 1 decimal place is 10.5. Question number 3. Here's a right angled triangle. Labelled it again, hypotenuse, opposite, and the adjacent. We're using tan because we know the adjacent and the hypotenuse, so tan equals opposite over adjacent, so it's 4 over 10. Because we're finding an angle, it's using shift tan, and to 3 significant figures, it's 21.8 degrees. These should be relatively simple 3 marks for you. Question 4, area of the triangle. Area of the triangle is base times height, so 8 times 7, or 7 times 8, divided by 2, which is 28 centimetres squared. That is an extremely easy 2 marks. If you consider in the question before, you were getting 2 marks for using sine, cos and tan. So area of triangles you should get right. The next question, we're asked to find the length of AC. You could use sine, cos and tan for this, but there's not a lot of point, because if it's a right angled triangle and you know 2 of the lengths, you can use Pythagoras to work it out. Here's my workings for it. A squared add b squared is c squared. So at 7 squared add 8 squared, and so on, and follow it down. And you should have got 10.63 because it's to 2 decimal places. Question number 5. There's a right angled triangle. Work out the area, base times height divided by 2. 2 marks easy. And work out the length of the long side. So it's 6 squared add 14 squared. And follow those workings through. You should get 15.23. Pythagoras again for that one. Question number 6. Well, it's not number 6, but it's the next question here. It's a right angled triangle. Calculate the angle y. So label your sides up. You've got the hypotenuse, which is your long one, opposite here because it's opposite the angle, and the adjacent is the other one. Here's my reminder here. Some old hags carry a huge tub of ale. So we're using tan because we know the opposite and adjacent. So tan y is 32 over 46. Because we're finding an angle, you have to use shift tan. And to 1 decimal place, it's 34.8. Next question over here. Got to find the area of a triangle. On the front of your exam paper, there is a formula sheet, and the area of a triangle is half AB sine C. So that's a half times A times B times sine C. We've got to label the sides. Notice that the formula says you know angle C, so we've got to relabel the sides on here. So we know that angle, so we'll call that angle C, which is a big C, so that's side little c. And it doesn't really matter for the other two. I call that angle A, so that's little a, and that's angle B, so that's little b, which is length B. Put your numbers into the formula, so it's a half times 15 times 9 times sine 110. There's your answer. And 3 significant figures, so it'll be 63.4. Question number 8. I think I might have missed question number 6 out very briefly. I'll go through this one in case I haven't. Find out this one here, length AB. Okay, so label your sides up. That's your hypotenuse because it's the long side. That's your opposite because it's opposite the angle, and that is the adjacent because it's the other one. We're interested in the adjacent, and we know the hypotenuse. So adjacent and hypotenuse is cos. Carry a huge, cos adjacent over hypotenuse. So cos 58 is x over 16. Multiply both sides by 16 to get x on its own. So 16 times cos 58 is that, and you should get 8.48 meters when it's rounded to 3 significant figures. Question number 8, a little bit of bearings working here. Town B is 4.5 kilometers due west of town C. So that's that angle there, that's that length there, sorry, not an angle. Town A is 2.4 kilometers north, so that's that length there. Calculate the size of the angle marked X. Okay, so label the sides up like you would normally do, treat it like a triangle. Your long side's your hypotenuse, there's your opposite, and there's your adjacent. So we're interested, we know the adjacent and the opposite, so that'd be tan again, tan tub of ale. Tan X is that over that. We use a shift tan when we're finding angles, so you should have got 28.072, which to 3 significant figures is 28.1. The next question, find the bearing of town C from town A. Find the bearing of town C from town A. So we're starting from town A, here we go, and we're going of town C from. So we're starting from there and we're going down that way because it says from town A. So we want to know that angle in there. Well, if we know that in a triangle there is 180 degrees, we just worked out angle X there, which is 28.1 in the previous question, so it's 28.1. We can work out what that angle is there, and that is 61.9. And we know that in a straight line there is 180 degrees, so it's 180 take away 61.9, which is 118.1. But to 3 significant figures, it is 118. Question number 9. Here we go. Area of the triangle. Base time. I think we've done this one before. Base times height divided by 2. 2 marks for that. Nice and easy. Work out the length AC. I'm going to call that A and that B. So 7 squared at 8 squared. It's Pythagoras. Follow your workings through. I'll leave them there. 2 decimal places, so it's 10.63. Question number 10. We're getting near the end here. Actually, not question number 10, but it's the next one. Find the angle. Find the size of angle Y. Okay, your long side's a hypotenuse. That's the opposite because it's opposite angle Y, the one we're trying to find, and that's the adjacent. It's the other one. So we know the opposite and adjacent. So we're going to use tan. When you find an angle, use shift tan. Get it in your calculator. To 1 decimal place, it is 34.8. Next one, this is question 10. Calculate the size of the angle BAC. So BAC. So it's that angle in there we are trying to find. I'll just shade it in so you can see it. We're going to use something called the cosine rule. It's on the front of your exam paper and it looks a little bit like this. It is A squared equals B squared add C squared take away 2BC cos A. Okay, so I've labelled my sides. So that's angle A, that's angle A, that'll be side A, angle B, side B, and so on. Let's work it through the formula. I've substituted all the numbers in, and I've simplified as we go along. So you should come out with something that looks along the lines of 19 over 240 is cos A. There's a bit of rearranging I've done there. So angle A would be 85.459, or to one decimal place, 85.5. I'll leave those workings there so you can pause it and just take a look at them and try and see what I've done. Question number 11. Calculate the length of CD. Well, that is that length there. Okay, what we've got to do is calculate the length of CB first, which I've done here. It's Pythagoras by the looks of it. Yes, it is, because 8 squared take away 3 squared equals CB. And I've worked that out to be 7.416. So when you know that is 7.416, and we want to find the length CD, we can use our sine, cos and tan. Label the sides up. That's the hypotenuse because it's the long one. I've called that the opposite because it's opposite that angle there. So we're going to use sine. So sine 50 is equal to the opposite over the hypotenuse. Hypotenuse, obviously, we're trying to find. Rearrange the formula, and you should get the hypotenuse is 9.68 to 3 significant figures. So 9.68. The next question is calculate the length of CE. What I have done is I've copied this triangle here from CDE down here, just to make it clearer for myself, and I've labelled the sides slightly differently as well. So we know that's 40 and that's 19, so we know that is 40 and that's 19, and we're trying to find length BC here. So I'm just going to refer to this triangle now. We're going to use the cosine rule again, and just plug your numbers in. You've got to relabel the sides so it all works. We're going to use cos A because cos A is the big one. Cos A is the only angle that we know. Follow it through, do a little bit of rearranging, and hope